Okay, last page of 9.2. So page 4 of 9.2. Just like we did with the population proportion in 9.1, we can determine the sample size needed to estimate mu within a given margin of error. Okay, and here's the formula that we use to do that. Okay, notice that we're using our critical values, our z-scores again for critical values, not our t-scores, right? This is because using the t-scores requires us to know the degrees of freedom, which requires us to know the sample size. Since the sample size is exactly what we're trying to find, that's a problem, right? However, the use of z sub alpha over 2 here is justified because the t-distribution approaches the standard normal distribution as n increases. So kind of built into this formula is the assurance that n will be large enough to justify the use of z sub alpha over 2 anyway. So let me give you a couple examples computing the sample size that you need. Okay, this says a researcher wanted to determine the mean number of hours per week, Sunday through Saturday, the typical person watched television. Results from the Sullivan Statistics Survey indicated that S equals 4.5 hours. Part A says, how many people are needed to estimate the number of hours people watch television per week within a 2-hour margin of error and with 95% confidence? Okay, so how many people are needed? Right, they're asking you what is the sample size that you need, right? So we're looking for the sample size. Well, up here we said the sample size that we need, n, is approximately z sub alpha over 2 times s divided by e squared. Let's see if we can find those pieces of information. Okay, for z sub alpha over 2, first we need to figure out what alpha is. Alpha is related to the confidence level. Our confidence level here is 95%. So we're going to say, since the confidence level is 95%, that means that alpha is what? So you should think about it. The alpha should be 0.05. That means that z sub alpha over 2 is going to be z sub 0.05 divided by 2. That's z sub 0.025. And we use the standard normal calculator to get that value, right? I'm not going to switch you over to StatCrunch. I'm just going to do it myself. So we go to Stat, Calculators, Normal. We change so that we're looking at an area to the right. We want that area to be 0.025. And we should get about 1.96, right? So this is about 1.96. We did a bunch of these in 9.1. So if you're like, what did he do? How did he get that number? Review your 9.1 stuff, right? But we went to Stat, Calculators, Normal. And then we put in this number for the area, okay? So we've got z sub alpha over 2 now. It's about 1.96. S, standard deviation. It says results from the survey indicated that S was 4.5. Okay. E, our margin of error. It says how many people are needed to estimate the number of people within a 2-hour margin of error. So our margin of error should be 2. Okay, and that's all there is to that. Let's see what we get. 1.96 times 4.5 divided by 2 squared is about 19.4 whatever, right? 19.4. But remember, on these kinds of problems, if you need at least 19.4 people in your sample, then really you need 20 people in your sample, right? So we're going to say n equals 20, right? Right, we always round up. Okay. So that's that one. Part B is related. It says how many people are needed to estimate the number of hours people watch television per week within a 2-hour margin of error and with 90% confidence. Okay, so this time, in part A, we want it to be 95% confident. In part B, we're okay with only being 90% confident. Now, what do you think would happen to the sample size? If you're okay with being less confident that your interval contains the true, whatever, if you're okay with being less confident, then it seems like you could get away with obtaining less information, right? It seems like you should be able to get away with having a smaller sample size. So we should expect the sample size to decrease. Let's see, right? First we need to find z sub alpha over 2, right? Our confidence level in this problem is 90%. That means that alpha is 0.10. Okay, so we're looking for z sub 0.05. I've already got the normal calculator open here, so I'm going to change the area to 0.05. And the corresponding critical value is about 1.64. Okay, let's plug that into our formula. So n is going to be approximately z sub alpha over 2, which we just computed, times s, which hasn't changed, divided by e, which also hasn't changed, squared. Let's see, 1.64 times 4.5 divided by 2 squared is 13.6-ish. So really we would say n equals 14. So yeah, sure enough, right? Our sample size decreased. So that does it for 9.2. Here's your homework assignment. You can use StatCrunch on all of these problems. Even though we worked out one of these things by hand, you don't have to do any of them by hand. You can just use StatCrunch on all of them. Even if the book says to do it by hand, just use StatCrunch. Okay, that's it.